Hello everyone, welcome to another Q&A session here at The Construct. My name is Rodrigo, and today I'll be answering this question I found on the ROS Answers website, in which this user is asking how to use the information from a camera, specifically a depth camera, to use the data and figure out the distance of an object the camera is seeing. So he's using a camera plugin and he wishes to know the distance of the object from a camera. So he's asking about the topics that are being published in that plugin. So what I'm going to do is I'm going to use a simulation in ROS1 that I have available, and then we'll bridge the topic with the ROS1 bridge in order for you to see the information, and I can explain it a little bit better and how to use this data for your programs to detect the distance of an object. So let's go for it. So I'm gonna go ahead here and open up the constructsim.com. And if you don't have an account, you can create one, and if not, you can start a new one. And usually what I do is I create a new ROSject over here. And in here you can create a new ROSject, select what you want. In this case, we're doing ROS2, so we can select ROS2 Foxy, for example. Call it Real Sense. Make it private, and then Real Sense, I'm calling it. I'm sorry, I didn't explain this. It's the Real Sense is a type of depth camera, and it's the one that I have available here. So it's the one that I'm going to use to explain it. And this is just a template ROSject. So you can hit create, and you'll see how it's been made here. So that's how you create ROSjects. However, I'm going to be using this one here that I said Q&A for today, because I already put the simulation in here. And don't worry, I'm going to be sharing this ROSject here, and you'll see this link in the description. You can also do this with your friends. You can share the ROSjects in order for you to be able to use the simulation without having to install it or anything like that. So I'm going to go ahead and run this one. So if you click on that run ROSject, once you copy that link it's down in the description of this video, you'll see that it's loading. So let me just go back really quick to show you our platform. It's just a really great place to learn robotics. We have over 50 courses that helps you from getting from a beginner to an expert in robotics. And in ROS1 and ROS2, you can do machine learning, autonomous navigation, manipulation with robot arms, and you also can practice with real robots. So it's just a really great way to start your learning for robotics, or to sharpen it. So I really recommend you guys create an account and start learning with us. All right. Okay, so good. Now that we're here, this is our ROSject that includes the simulation. So what we're going to do is first launch this simulation and the ROS bridge. So over here you can create new shells, which are just terminals, and we can actually rename them, which is really nice. So you keep track of everything. So we're going to name this the simulation. Over here we'll launch the ROS1 bridge. This is just a program that bridges topics and nodes from ROS1 to ROS2, because there's not a lot of simulations right now for depth cameras. So what I'm going to do is just use one from ROS1 and port it to ROS2 with this bridge. And over here we can say, well, I want to show you guys the visualization of this camera. So we're launch ROS2 here. But anyways, over here, first we're going to source noetic. Since in this ROSject, even though it's a Foxy distribution, we also have ROS1 noetic installed, precisely to deal with these situations where it's more convenient to have ROS1 and ROS2 in it. So we can first source noetic like this with this command, opt ROS noetic setup bash. And then we're also going to source the simulation workspace, devel setup bash. That's where our simulation is. So we're going to launch it. So for that the command is ROS launch, and it's URE gazebo, and the simulation that we're looking for is this one, UR3E.launch, like so. So to see the simulation, you can click on gazebo here, and you see that we have a robot arm. I'm not going to use it, I just need this guy right here, which is the camera. That's the simulation of a RealSense D435 camera. It's an Intel camera that has a depth and RGB cameras, so you can detect distance with this camera. And this user is using a multi-camera plugin with SDF. I'm not quite sure what it is, but it will be offering the same topics: camera info, image raw, points. So I'll just show you guys. So I could show you this in ROS1, but we're going to do it in ROS2 because this is the question that the user is asking. So in here, to launch the ROS bridge, you always have to source ROS noetic in this order, and then ROS Foxy or dashing or whatever distribution you have, like so. And then you can do ROS2 run, and it's ROS1 bridge. The name of the node is dynamic bridge, and we're going to bridge all topics. Okay, so you can see a lot of things showing up, which are the connections for the topic in ROS1 being sent over to ROS2. But let me just show you. In here, you can do a ROS2 topic list, and you'll see these topics, and they're just what the simulation here is offering. And what we're interested in are this wrist RGBD. It's just supposed to be an RGBD camera. And like the user says, he's asking, well, what do I use to determine the distance? He's asking image raw, the topic, and then the camera info topic. So he wants to use the information to identify the distance of an object. So first thing, the camera info does not contain information related to what the camera is seeing. It's just information about the camera itself, namely the field of vision, how wide the image is, how big it is. So if we do I'm gonna make this big. If we do a ROS topic, oh sorry, we're in ROS2, ROS2 topic echo of this camera info, let's say, we're going to see something like this. And like the user says he sees some weird parameters, and to be honest, I don't know what exactly what these parameters are, but these are related to the camera. So these are not things that the camera is actually seeing, but it also tells you, you know, where the frame is that the camera is publishing these images, the height and width of the image, the distortion model. So this is information about the camera, like the topic says. So you won't get any actually information about the distance of the object. What this user got it closer is using this image raw topic. But what that image raw topic does is actually the pixels, the intensity of the pixels. So an image is just a matrix of a bunch of pixels, and each pixel has a certain intensity. So if we do a ROS2 topic echo and RGBD, and we want the depth, and I think we'll see the image raw. There it is, image raw. We'll see these pixels that I'm talking about. But again, it's not actually the distance of the object. It's just in the third spot of the image, the pixel is 192, etc., etc. What we actually want to look at to see the distance is this, the points. This actually tells you at what distance each point that this camera is using, what is the distance of it. So we'll just wait for this to, because it's a big image, so it's just parsing it. Okay, let's try that again. Let's see what the topics we have. So ROS2 topic echo, and this is the one we want. While this is waiting, I'm actually going to launch ROS2 in another terminal so I can show you the actual image and you can visualize it. Oh, there it is. So here it's the actual points that you'll use in order to determine the distance of the object. Each one of these corresponds to, I think it's millimeters of each point that is bouncing back. So let me show you here. We're going to do an ROS2. ROS2 is used to visualize data, and in this case we want to visualize the depth information of the camera. So over here, I'm going to try and make this a little bigger. Okay, like this. We're going to select the frame onto which the image is being published, which is this one in this case, wrist RGBD camera link. And we're going to add by topic. And as you can see, this is the camera, this wrist RGBD, and it has two things. So for example, let's say we want to see the image of the RGB, which is red, green, and blue. So this is just like a normal image that we would see. It says no image, but now you can see, okay, this is what the camera is seeing right now. You can see kind of that this is the arm, so it's just kind of a weird angle, but you can see the arm here. But we don't want this. We want the information of the depth, which is what you use to get the distance. And we're going to actually look at this one. Points is the one I showed you. If I was to show you the image raw for the depth, you would see this weird image, which is just a representation of, I think maybe I can get rid of this. Yeah, a representation of depth in the image. So you can see the further you are, the lighter the image gets. But like I said, we don't want to use that. We want to use the points right here. And you should see something appear in the middle here. I'm gonna get rid of this so you can see it. So this is actually the point information that the camera is seeing. So if we want to zoom in a little, you'll see sort of a image of this arm. But what we're interested in are all of these points, like I said, that actually tell you the distance of the object. So this one right here, you can see this kind of U-shaped hole here actually represents the base of the robot. So this would be the base. So if we go to the simulation, you can see that the camera is actually looking at this, which is closer than, say, infinity over here. So that's what it represents. And that's what you see in this information. Each point corresponds to each one of these values. So this is the gripper part, the end of the robot, and this is the base. And since this is a simulation that has nothing else in it, all the rest of the points, go out to infinity. And in here, it's 0. So, because they don't return, so you would have a infinite value there. So that is actually the topic you want to use in order to determine how far an object is. So if you would look at the range of from here to here, you would see that you have actual values for the points, and then you can determine how far, let's say, the center of this base is. So yeah, that is pretty much how you use a depth camera to determine how far an object is. Let me know if you guys have any more questions. I'm going to put the link for this ROS check so you can launch the same commands that you saw in this video on your own. If you copy that link and paste it on your browser, you'll see the ROS check pop up, and you can run it and try it out for yourself and actually start making a node that uses this points topic and try and play with it to see what you can do with this information. Hopefully this video was useful, and I'll see you guys next year, because we're in December 27th. So for the next video, again, I'll see you guys next time, and see you guys later. Have a good week. Bye bye, guys.